Introduction to Case Studies in Smart Contract Failures. Module 6, Video 6. In this video, we are going to explore some of the most significant failures in smart contract history. By studying these past mistakes, we can understand common vulnerabilities and learn how to prevent them. This knowledge is essential for building more secure and reliable smart contracts. We will review some of the most notable smart contract failures that have occurred. The DAO hack, 2016. Let's start with one of the most infamous incidents in blockchain history, the DAO hack in 2016. The DAO, or Decentralized Autonomous Organization, was a crowdfunding platform built on the Ethereum blockchain. It allowed users to invest in projects and participate in decision-making through voting. The hack exploited a re-entrancy vulnerability in the DAO's smart contract. This allowed the attacker to repeatedly withdraw funds from the DAO contract before it had finished processing the first withdrawal. In the given example, the attacker can call the withdraw function repeatedly. To prevent re-entrancy attacks, we can use techniques such as re-entrancy guards. These are Boolean variables that are set to true when a function is called and reset to false when the function finishes executing. Additionally, we can use the checks effects interactions pattern. This pattern ensures that all checks and state changes are performed before any external interactions are made. By doing so, we can prevent attackers from manipulating the contract state during re-entrant calls. Here's an example code how we can implement it. Parity multi-sig wallet hack in 2017. Parity Technologies developed multi-sig wallets that required multiple signatures for transactions, providing enhanced security. Unfortunately, an uninitialized variable in a Parity library contract led to a severe vulnerability. An attacker could exploit this to initialize a wallet with themselves as the owner by passing the multi-sig requirement. This vulnerability resulted in the theft of $30 million worth of ETH. This code shows how the vulnerability was in the way the init wallet function was implemented. The attacker could once again repeatedly call the init wallet function, each time setting a new owner for the wallet, effectively becoming the sole owner. To mitigate such vulnerabilities, it's crucial to ensure that all variables are correctly initialized before use. Additionally, we should restrict access to initialization functions by using access modifiers like only once. This ensures that the initialization function can only be called once, preventing attackers from reinitializing the contract, as shown in the code here. The SpankChain hack in 2018. SpankChain utilized payment channels for off-chain transactions to reduce on-chain fees to improve efficiency. The hack exploited a vulnerability in the withdraw function of a payment channel contract, allowing the attacker to repeatedly call the function before it finished processing the first withdrawal. This resulted in the theft of $38,000 worth of ETH. To prevent such issues, it is important to use secure transfer methods and robust libraries for transferring Ether. Additionally, implementing proper access controls and validations ensures that only authorized transactions are processed. The Bancor hack in 2018. Bancor is a decentralized exchange platform that allows users to trade cryptocurrencies without centralized order books. The hack exploited a vulnerability in the smart contract logic, specifically in the way the platform handled token reserves and price calculation. The attacker manipulated the system, resulting in the theft of $23.5 million worth of cryptocurrency. The vulnerability stemmed from the lack of proper validation in the convert function. The attacker repeatedly called the function, draining the from token balance without providing any corresponding value. To secure decentralized exchanges through validation and checks are essential. Every transaction should be scrutinized to prevent unauthorized actions. This includes verifying user balances, token availability, and the validity of trading parameters. Here is an example code. Finally, let's examine the DeFi exploit of 2020. This targeted a vulnerability in a decentralized finance protocol involving flash loans. Flash loans basically allow borrowers to take out large amounts of cryptocurrency instantly with the requirement to repay the loan within the same transaction. However, if a protocol doesn't properly validate the loan repayment, attackers can manipulate the system and drain funds. Here's an example of a vulnerable flash loan implementation. This code shows that how an attacker could borrow a large amount of cryptocurrency, manipulate the price of the asset, and repay the loan with a significantly lower value. To prevent such exploits, comprehensive validation and checks at every transaction stage are necessary. Ensuring atomic transaction is also vital. Atomic transactions guarantee that all operations within a transaction either succeed or fail together, preventing partial execution that could leave a protocol vulnerable. But what are the lessons we have learned from these past failures? The case studies we have reviewed highlights several crucial lessons for smart contract development. Firstly, implementing secure coding practices such as input validation, thorough testing, and proper error handling is essential to mitigate vulnerabilities and protect against exploits. Regular audits and continuous monitoring are vital for identifying and addressing potential vulnerabilities. Independent audits by experienced security professionals can help detect flaws in code logic and design. Continuous monitoring systems can track unusual activity and provide early warning signs of potential attacks. Thorough validation and checks are essential to ensure that every transaction is legitimate and secure. This includes verifying user balances, token availability, and the validity of trading parameters. Best practices for smart contract development. Following best practices ensure secure coding and helps avoid common vulnerabilities. Regularly review and test your smart contract code to identify potential issues. Implement input validation and error handling to mitigate risk. Use secure libraries and contracts that have been audited by trusted sources. Regular security audits help identify vulnerabilities and mitigate potential threats. Hire experienced security professionals to conduct comprehensive code reviews and audits. Implement continuous monitoring systems to track unusual activity and identify potential attacks. Employ well-audited libraries and frameworks that have been thoroughly tested and vetted for security. This reduces the risk of inheriting vulnerabilities from external components. Tools for auditing smart contracts. Automated tools are invaluable for identifying potential vulnerabilities in smart contract code. These tools can analyze code statically, identifying potential security flaws without actually executing the code. This early detection is crucial for preventing costly exploits. Several popular tools are available for smart contract auditing. Mythics, Slither, and Oyente are widely used and provide comprehensive analysis. These tools can detect a range of vulnerabilities, including reentrancy, integer overflow, and logic errors. Integrating smart contract auditing tools into continuous integration and continuous delivery pipelines ensures continuous security. This automated process scans code for vulnerabilities before deployment, preventing compromised contracts from reaching production environments. In conclusion, we have explored several key case studies of smart contract vulnerabilities, highlighting the importance of security in decentralized applications. These case studies serve as valuable reminders of the constant need for vigilance and proactive security measures. By implementing the lessons learned from past failures and adhering to best practices, we can enhance the security and reliability of smart contracts, safeguarding user assets and maintaining the integrity of the blockchain ecosystem. For any further doubts and queries, please reach out to us on our Discord server. Thank you.